In the vastness of the universe, Earth is a fragile oasis, a small blood suspended in a dark sea of emptiness. As it spins in orbit, it is bombarded from every direction by the solar wind, a constant stream of charged particles racing from the sun at speeds reaching hundreds of kilometers per second. These particles, mainly electrons and protons, carry immense energy. Without protection, this invisible storm would strip away our atmosphere, wither our oceans, and leave the planet barren. Yet, Earth is not defenseless. Unlike other planets, Earth has an invisible shield, a powerful magnetic field that acts as a sentry guarding against the sun's relentless barrage. This shield is not made of metal or stone, but of something far more fundamental: magnetic forces. It bends the solar wind around our planet, directing it safely into space and protecting life as we know it. This magnetic field, known as Earth's magnetosphere, is one of our planet's most essential, yet least understood, defenses. Deep beneath our feet, in the fiery core of the Earth, the story of our planet's magnetic field begins. Around 3,000 kilometers beneath the surface, Earth's outer core is a turbulent sea of molten metal, primarily iron and nickel. The heat of this molten mass, combined with Earth's rotation, creates convection currents, with hot material rising and cooler material sinking. As these currents move, they generate electric currents. And where there are electric currents, magnetic fields are born. This phenomenon, known as the geodynamo, is what powers the Earth's magnetic field. It's like a giant, natural generator, constantly creating and reshaping magnetic forces. These magnetic fields extend far beyond the surface, creating a protective bubble, the magnetosphere. This invisible shield stretches tens of thousands of kilometers into space, far beyond the orbits of the Moon and the satellites that orbit our planet. It is a dynamic, ever-changing field, constantly adapting to the pressures of the solar wind. Without it, the very fabric of life on Earth would unravel. The solar wind is relentless, an unyielding stream of charged particles that travels at incredible speeds. Without a barrier, it would bombard Earth's atmosphere, stripping it away over time. The magnetosphere, however, intercepts this solar wind, diverting most of it into space. But the force of the particles still exerts pressure on the magnetic field, creating dramatic effects. At the magnetosphere's boundary, the solar wind compresses the field, like air blowing against a balloon. This compression is greatest on the side of Earth facing the sun, creating what is called the bow shock, where the solar wind slows down and deflects. On the opposite side of the Earth, the magnetic field stretches out into space, forming a long, trailing tail, much like a comet's. Some particles, however, do manage to slip through, especially near the poles, where the magnetic lines are weakest. These particles are funneled toward the magnetic poles, where they collide with the gases in Earth's upper atmosphere, creating the mesmerizing light displays we call the aurora borealis and aurora australis, the northern and southern lights. It's as if Earth's magnetic field has turned the sky into a canvas, painting brilliant strokes of light to remind us of the constant battle it wages in our defense. Long before we understood the science behind Earth's magnetic field, ancient humans witnessed its effects. Across the northern and southern latitudes, the auroras dazzled our ancestors, who likely saw them as omens or messages from the gods. These lights were mysterious and beautiful, but the invisible forces behind them remained unknown. But the magnetic field's influence wasn't limited to the sky. In ancient China, magnetic stones known as lodestones were observed to align themselves with the Earth's magnetic field. This discovery led to the invention of the compass, a tool that revolutionized navigation. The compass allowed sailors to navigate the oceans, guiding explorers toward new lands and untold discoveries. Even in those early times, humans unknowingly relied on the Earth's magnetic field to orient themselves, unaware of just how integral this invisible force was to their survival and progress. Fast forward to today, and our understanding of Earth's magnetic field has deepened. Modern technology now allows us to study and monitor the magnetic field in ways ancient peoples could never imagine. Satellites, powered by the very technology that depends on the protection of the magnetic field, orbit Earth, sending back real-time data on the state of our magnetosphere. These instruments help scientists track space weather, solar flares, coronal mass ejections, and geomagnetic storms that can impact everything from our communication systems to our power grids. Solar storms, while spectacular to watch, can pose serious threats to our technological infrastructure. A powerful coronal mass ejection, for example, could disrupt satellites, GPS navigation, and even cause power outages on Earth. These storms, caused by intense bursts of solar radiation, interact with the magnetic field, and depending on their strength, can cause geomagnetic storms. These storms have the potential to fry satellite circuits, disrupt air traffic, and even trigger blackouts that affect millions of people. So, while the magnetosphere is our shield, we are still at its mercy when it comes to the intensity of solar storms. That's why scientists across the globe are constantly monitoring space weather, tracking solar activity, and studying the behavior of the magnetic field to better prepare for what's to come. Earth's magnetic field is not a static, unchanging force. It is dynamic, always shifting and evolving. Over time, the strength of the magnetic field fluctuates, and every several 100,000 years, the magnetic poles undergo a reversal. Magnetic north becomes magnetic south, and magnetic south becomes magnetic north. This process is known as geomagnetic reversal, and while it may sound dramatic, it is a natural event that has occurred many times throughout Earth's history. The last reversal took place about 780,000 years ago. During these flips, the magnetic field weakens, which makes Earth more vulnerable to solar radiation. While no mass extinction has been linked to a reversal, the temporary weakening of the field can still pose challenges. Today, the magnetic field has been weakening slowly over the last few centuries, particularly in an area known as the South Atlantic Anomaly. Could we be nearing another magnetic reversal? It's impossible to say for sure, but scientists are keeping a close watch. These flips are slow, occurring over thousands of years, but the impact they could have on modern technology makes it all the more important to understand their potential effects. In the grand scheme of the universe, Earth's magnetic field may seem like an invisible force, a quiet guardian in the background. Yet it is more powerful than we often realize. It protects life on this planet, stabilizes our atmosphere, and shields us from the cosmic radiation that could render our world inhospitable. Without this shield, Earth would be a very different place, a barren world, its atmosphere torn away, where life could not survive. Our magnetic field is a cosmic gift, a force that allows life to thrive in the delicate balance of radiation, gravity, and time. As we look toward the stars, we realize just how rare and precious this magnetic shield is. Earth is one of the few planets we know of that is protected by such a field, and it's this field that makes our world unique in the vastness of space. It is a force we cannot see, but one that surrounds us every moment of every day. The Earth's magnetic field is a constant, ever-present force, shaping our past, present, and future. In the silence of space, Earth stands protected, shielded by an invisible force. This force, the magnetic field, is as vital to our existence as the air we breathe, the water we drink, and the warmth of the sun. It is the silent guardian of life on Earth, and its importance cannot be overstated. The magnetic field will continue to protect us for as long as the geodynamo spins deep within the Earth's core.